So in this video, we're going to talk about congruent triangles. I'm going to define them and talk about how to prove two triangles are congruent and do a few examples, and then we'll build off of there in class. So congruent figures in general are figures that have corresponding angles and corresponding sides congruent. And so what that means is for congruent figures, they're the same shape and they're the same size. And so they're exact copies of each other. They may be like turned or reflected differently, but they're exactly the same size and shape. So in this class, we are mostly going to focus on congruent triangles. And what we use to describe congruent triangles is we use this congruent statement. So this is called a congruent statement. And the congruent statement tells me what is congruent in my triangles. So this is telling me triangle XYZ, this first triangle on the left, is congruent to STR. And the order of these letters are really important because they tell me which angles are congruent and which sides are congruent. So because the first letter is X in this triangle and the first letter is S in the second triangle, we know that angle X is congruent to angle S. And I put again the same number of arcs to show that they're congruent. So one of the congruent angles is angle X, which is congruent to angle S. And because there's triangles, there's going to be 3 angles in each one. So there's 3 pairs of congruent angles when we're talking about 2 congruent triangles. Okay. So then my middle letter is Y, and my middle letter in that second part of the statement is T. And so angle Y is congruent to angle T. So I'm going to put 2 marks, 2 arcs on them to show that they're the same measure. And then the third angle, the last angle in each one is Z and R. So angle Z, so I could do 3 arcs, or you can also do, again, arcs with like tick marks on them. Just make sure they have the same markings on the corresponding angles. So angle Z is congruent to angle R. And so these parts are called corresponding parts. They're the parts that are congruent. So X and S are corresponding angles, Y and T are corresponding angles, and Z and R are corresponding angles. Okay. So we can also use the statements to help us find sides that are congruent. So XY is first in the first statement, and ST are the first 2 letters in the second statement, which means the side XY is congruent to the side ST. And so again, we're going to name the 3 pairs of congruent sides. I'm going to put 1 tick mark on each to show that those 2 sides are congruent. Then we know if I do the second 2 letters, YZ, that is going to be congruent to the second 2 letters in the second part, which is TR. And so I know that YZ is congruent to TR. And then my third side is going to be the longest side. That's the first letter and the last letter. So XZ and SR, those 2 sides are equal. So I'm going to indicate both of those with 3 tick marks to show that they're congruent. And so we have XZ is congruent to SR. So this, again, this congruent statement tells me what is congruent. Sometimes the triangles are it's gonna be easy to tell by the picture what's congruent, and sometimes the triangles are not drawn to scale. So you do have to go by that congruent statement. Now, we don't really have to know the 3 angle measures and the 3 side measures. We don't have to know that all of those are congruent in both triangles. We actually only really need 3 pieces of information. And if we have a certain set of 3 pieces of information, it's enough information to prove the 2 triangles congruent. And so there are 5 ways we can prove triangles congruent. So the largest side of a triangle is always opposite the largest angle. The smallest side of the triangle is opposite the smallest angle, and the middle side is opposite the middle angle. Because of this unique relationship, we can determine if triangles are congruent in the following ways. So if I just know that all 3 sides of 2 triangles are congruent, if I know nothing about their angles, but just that the 3 sides of the 2 triangles are congruent, that's enough information to state that the 2 triangles are congruent. And the reason we give is called a theorem or a postulate. The reason we give in that case is called side, 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 which is SSS, which means I have 3 pairs of congruent sides. So what that looks like is if I have 2 triangles, if I have 3 pairs of sides marked congruent, so if I have like AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, I can say these 2 triangles are congruent by side, side, side. And so I can state triangle ABC is congruent to triangle, and I have to match it up. So A is between 1 and 3, and D is between 1 and 3. So I would go D, and then I would go to B, which is between 1 and 2, and so is E, D, B, F. And so I can say these 2 triangles are congruent just knowing that I have 3 pairs of sides that are congruent. And I don't have to know anything about the angle measures. So that's one way to prove triangles congruent. A second way to prove triangles congruent is called side included angle side. And we usually just say SAS for side angle side. And so this looks like if I have 2 triangles, and they don't have to be, again, the same direction. We can kind of draw them differently. If I have 2 triangles, and I have a side that's congruent, an included angle, and I'll explain what that means in a minute, and another side that's congruent, this is enough information to state that these 2 triangles are congruent. I wouldn't have to know the third side and the other 2 angles. If I knew these pairs of things were congruent, then I would definitely be able to say, yes, these 2 triangles are congruent. So side angle side, again, looks like I have 2 pairs of sides congruent. So I have 2 different pairs of sides that have matching tick marks. And I have the angle in between the 2 sides. So the angle has to touch the 2 sides that are marked congruent. So this angle touches those 2 sides, and this angle touches those 2 sides. So we could say that triangle ABC is congruent to triangle, and again, we're going to match them up. So A, if you look at the markings, would be the same as F, because it's by that 1 tick mark and no tick marks. And then B has that angle that's congruent to E, so E would come next to match B, and C would go with D. Okay, so you have to be very careful when you're saying the congruent statement that they match up. And we could say they are congruent by side angle side. So that's the second way. The third way is angle included side angle. And we call that ASA for angle side angle. So if I have, again, 2 triangles, and if I have the following information, it's enough to prove the triangle's congruent. So if I have an angle, an included side, and an angle of 2 triangles being congruent, then the 2 triangles are congruent. So if I have B is congruent to E, and then I have angle C congruent to D, The included side is the side that's touching those two angles that are marked. So the included side would be BC on this one and DE on this one. And so if I have this angle, side, angle, I can say the two triangles are congruent. And again, I don't need any more information. So I could say triangle ABC is congruent to triangle, and I'm going to match them up again. So A doesn't have a mark and F doesn't have a mark, so they match. B has one mark and E has one mark. And then C has two and D has two. So these are congruent by angle, side, angle. The fourth way is angle, angle, unincluded side, which we just usually say angle, angle, side, which is AAS. And so this is similar to this one, but it's kind of a different order. So if I have the same setup, and I have these two angles congruent. Angle B is congruent to E and C is congruent to F. Angle, angle, side looks like the non-included side. So the side not directly in between the two angles that are marked congruent to the other diagram. So it could be AB. I could have also done like AC with DF. It would also be angle, angle, side. But these two triangles are considered congruent. So triangle ABC, again, matching them up, it would be, in this case, I did it the other way, D, E, F. Okay, so I'm just matching up my markings again. And this one would be angle, angle, side. So just notice the difference because these are different theorems. When the tick mark is between the two angles that are marked congruent to the other angles, then it's angle, side, angle. And when it's not directly between, then it's angle, angle, side. And then the last one doesn't come up as often, but the last one is called HL, hypotenuse leg. And this only works for right triangles. So if you have the hypotenuse and one leg of two right triangles congruent, then the two triangles are congruent. So just like a reminder from a right triangle, the hypotenuse is always the side that's across from the right angle. And the other two sides that create the right angle are called the legs. So hypotenuse leg and again, if I draw these a different orientation, because that's will happen a lot in the problems that we see. So if I have a right triangle and the hypotenuse of the two triangles, or the hypotenuse of the two triangles are congruent, and one pair of legs of the two triangles are congruent, then I can say the triangles are congruent by hypotenuse leg. Okay? So not every right triangle is HL, but if it's a right triangle, I would check and see if a leg and the hypotenuse of two triangles are congruent. If so, you can say HL. So I would say triangle ABC is congruent to triangle. Okay, again, matching up. A is going to go with D because it's between the one tick mark and the no tick marks. B is the right angle, E is the right angle, so that's going to come second, and then C and F would go together. And we would say by HL, hypotenuse leg. So those are the 5 theorems that work. There are 2 that don't work, which means if I have this information, it's not enough information to say the 2 triangles are congruent. They might not be. So if we have angle, angle, or angle, 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 which means if I have 2 angles of a triangle congruent, so think like an equilateral triangle. I can have equilateral triangles where the angles, like any equilateral triangle, the angles are always 60, but they don't have to be the same size. Like this one, the sides could all be 2, and this one, the sides could all be 6. And so just knowing that 2 corresponding angles are congruent or 3 corresponding angles are congruent is not enough information to say the 2 triangles are congruent. They might not be. I would have to know a side length to know that they're actually the same sides and not, it's called similar, which we'll learn next unit or the next topic. The other one is called side-side angle or angle side-side. And it's if 2 sides and a non-included side are congruent. So they're going to draw it like this, and they're going to draw them so they look the same size. But it's just saying that if I know this information, it wouldn't be enough to prove the 2 triangles congruent. So if I have an angle and 2 pairs of sides where that angle is not the included angle, so it's not the one in between the 2 pairs of corresponding sides, this is considered either angle side-side or side-side angle. And we would say not enough information or not congruent. We say that sometimes. So the only exception is if it's a right triangle, then it's actually hypotenuse leg. So this one is actually angle side-side. I have 1 angle and 2 sides, and it's the not included angle. But if it's a right triangle, then I know the 2 triangles are going to be congruent. The reason is because the other 2 angles would have to be acute if it's right, and so therefore there's only 1 possible triangle it can be. But if it's not, then you could have 2 different triangles. So there is an applet that I want to show you to show here. So if I'm given 2 sides and a non-included angle, side-side angle or angle side-side, it's not enough to prove congruence. The reason is the triangles could be congruent. So I have this angle A is congruent to angle P, I have AB is congruent to PQ, and BC is congruent to QR, and they are congruent. But I can have the same congruent parts, and I can change this angle B instead of to being this obtuse angle to be an acute angle. And I get 2 different triangles, but I still have angle A congruent to angle P. I still have AB congruent to AQ or PQ, and BC congruent to QR. And so just knowing that information being congruent is not enough information to prove them, because I can actually get 2 different triangles, one that is congruent and one that's not. And that's why we say that one does not work to prove that they're congruent. So one way to remember it is this, like, spells a bad word, can't have bad words in geometry. So that's how you remember, like, that is not a valid reasoning. And the other one, I don't know if this will help you remember it, but I would tell my students in high school, remember, like, AAA doesn't work. So AA or AAA does not work. Okay, so those are all the theorems. I'm going to make more videos of, like, examples with them.